Okay. Yeah, I try to make sure that we record everything, and this session gonna be uploaded later on after I cut down all the date times. Okay. So for the general announcement, I would like to mention that maybe, just maybe, I'm not really sure how good things gonna be for the COVID-19, but in many case and with high possibility right now, maybe we cannot do the final exam. So in that case, we need to have meeting among faculty members about how to take care of this situation. I'm not prefer to put a lot of project on your guys, but if that's the last option that we have, then maybe, yeah, unfortunately, we need to have like one big project or report, or I don't know, a lot of assignment to getting some score as a replacement of final exam. Just want to making announcement right here first. And yeah, I'm not really sure. The situation is changed day by day, as you've seen. I will keep updated in the Facebook groups. Hopefully we can find a better way out together. So for many of you who doesn't have like good internet connection right there at your house, and you might encounter with some problems. Yeah, maybe in many cases you cannot like see this live clearly, or the voice is become laggy. I try my best to motivate, like mitigate around that. We're gonna re-upload this session in YouTube for you guys, so you can listen to it again on demand. But then the limitation is that if you want to ask a question or discuss with me or do some like Q&A, we need to do it here at the live chat, or you can open your microphone to do that. Okay, is that everything clear? So the session gonna have like two main screen that I'm gonna switch back and forth. It's gonna be this one, and another one is a whiteboard. So for whiteboard itself, I think you guys can written it down as well. Like, can you write down something on the whiteboard? On the whiteboard? Could you try it? Like that, please, anyone, please try to write down something, like maybe write your name, type something down, or draw some image. Can you do that? I think it's gonna be the share. Yeah, in Zoom, you have to click at the screen and then check at the whiteboard. Then I think you can join and written it down as well. Can you do that? Can anyone do that? If not, I need to check about how to setting it up. Oh, okay, somebody just write it down. Okay, good, cool, cool. Hi, yeah, hi. Okay, great. Yeah, I think you can write something down or delete something out using eraser. For anybody who say you can't, did you access to the whiteboard, or you just written down in the share screen? For anyone who can write down something, please tell your friend in chat as well, like how you do that, okay? Okay, so I think it's time, and I would like to start this session. So the idea is that the class gonna separate into two main kind of situation, like section. I prefer to make it like this simply because I'm considerate about your internet connection, and I'm not really sure how much can we do with the live. So for lecture, I'm gonna make it to be video on demand. So we separate the lecture into like series of video, gonna upload in YouTube in the same playlist. And then you can listen to it, check it out anytime you prefer. And you can keep repeat checking it out, or looking for more materials online to supporting it. And if you have any question, if you want to discuss about anything, please written it down in the Q&A post in Facebook groups. Then following that Q&A post, I'm going to pick up some question. It depends on how many questions you have. I'm sorry. If we didn't have, I'm sorry, it's too close to the microphone. If we didn't have too much question, what I did is we gonna run through every question in the post. If we have many questions on there, I'm gonna pick some of them that look very, very useful for everyone to see, like the idea behind that or solution behind that. So right now for this lecture, since it's about like some basic kind of algorithm searching and sorting, which is highly related to data structure. If you look at the video, you might see that, okay, by these couple of algorithms, the idea is that like those algorithm itself need to have good data structure to support it. So as I say, like for searching, I put the searching before sorting simply because like when we explain it, you're gonna see clearly how its work correlated to each other's. Because for searching itself, to make it more effective or more efficient, you need to have sorted data. And thinking about the real world situation that maybe the input in your Facebook, in your mobile phone, or order of the food in Grab application, you can imagine that it came with a random order, right? From like, I don't know, maybe ordered a small amount of food to the high amount of food, but then it comes with a random chunk. But then if you want to searching for some things in that kind of random order generated, the better way to do that is you sort the data first and then you search later on. Simply because if we look at this linear search, which is the search algorithm that like most basic one for sequential search, the idea behind it is just searching for like, now you can open the microphone and then we can have like two-way communication. Please, I mean, if there's no one reply me on chat or by microphone, everything gonna go like in pretty quick because it's like I'm talking to myself. And this live session gonna be a little bit useless. So yeah, the idea of linear search itself is more like you searching for in like linear order, linear direction. Okay, so you have a couple of information here. So if you have text, like the list, okay, and then you have random numbers here. for example, then what happens is that if you do the linear search, you just identify the direction, like you want to go to left to right, or you want to go from like right to left. It also depends, because sometimes you input data in stack or in queue. So in stack or in queue, the direction of search should follow the way data are being organized inside, right? So in queue itself, you're gonna search from one direction like this for sure. But then for the stack, the last input gonna be the one that being searched. So it's look like looking from the last information to the first information that put on the array or linked list, or your stack, your queue implementation. The way they did is that you have the number that you're looking for example, like you're looking for number 2. Okay, that's, and you're asking for like where it is. Then the idea is like you go for one direction until you find that numbers. Then the good point of this kind of algorithms, I mean, it's simple, it's straightforward, but then you can see that it's not efficient at all, because if this array is not like 5 number array, but it's become something like, I don't know, if you put it, this one is like 10 million data long of like list of integer, for example, you have like 10 million integer on the line, and the number that you're looking for is in like 9.9 million position. So the searching is going to be very, very slow, because you need to look at each information and compare it one by one and try to take a look at it. That's why linear search is not that efficient. But in the other hand, if your data is not sorted, if your data is in the random order, then we cannot much develop any kind of algorithms that can predict or make general efficiency among of the searching type, because you not really know like, okay, data on the left is going to be low number, or data on the right is going to be higher numbers or not, because the data is not organized at all. That's going to create a lot of difficulties to do any kind of searching. So one way to solve this is by data structure itself. If you create data structure that have input function, which is good enough to, instead of put data into the back of array, but then they insert the data in the sort position beforehand, then you're going to resolve most of the like hectic problems. So please keep it in mind, because that kind of ideas that you should have in your mind right now, that okay, you learn data structure, you learn algorithms. The thing that you need to consider is efficiency, effectiveness of the program that you write down. So in that case, make input function instead of like put something in by scanf and add it to the last place of array or last place of linked list. It's going to be more efficient in the long run. Okay, is that clear? Yeah, I want to know that everyone here would have talked for a while. Okay, good. Then the idea is that if we can sort the data, then we can create some complex algorithms, mostly iterative. So the interval or iteration, the word that I use a lot in this lecture, interval, it means something that you repeat it many, many times. So some algorithm that can repeatable their process. And then you can imagine that you can write it down in recursive function. Okay. And then, yeah, you look at the binary search. the idea is pretty simple, is that it's use divide and conquers kind of strategy. So I'm not really sure that you guys heard this word before. I'm talking about it in slide, but I think it should be mentioned in basic C languages class, but not really sure that you guys remember it. So did you know the divide and conquers? Not, I didn't see any response. So don't learn in previous class. Okay. Okay. So divide and conquer is kind of strategy. Have you ever played some games like 20 question games? It's kind of kids game in Europe, but not, maybe not here in Thailand. So it's like the games that one person imagine solution in their mind. So it's going to be something like, yeah, my drawing is going to be pretty bad. But then we have Mr. A and we have Mr. B here playing together. So A have to imagine about one item in their head. So maybe iPad, I don't know. And then within 20 questions, we have to guess the answer within 20 questions. That's the ideas of the game. So it's like searching. We have to search for the solution within 20 questions. And the question is how B gonna achieve that. So if B doing linear search, what B guessing is gonna be something like, oh, hello, is there anyone open the microphone? You can open the microphone whenever you want to raising the question or anything, but please to avoid some noise in your house, please raise it down, okay? If you're not gonna talk anything. So the idea of linear search is that because B have no ideas what A thinking about, so B just asking, like raising the names of the item one by one, like apple, and then A might say no, then guess again table, and then it's gonna be another no, and then part, and then blah 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 until it's end of 20 questions. Then by luck, by chance, by some body language, maybe B can see some hint and find out that A thinking about iPad. But then divide and conquers gonna do something else. Oh yeah, I forgot to mention that the only thing that A can answer is yes and no in this game. So another way around of divide and conquer strategy is that divide the possibilities in half and then check like which half is the solution space. For example, B starting to ask, is it electric device? If B asking this kind of question, then A answer yes. So B know for sure that B divide all the item in the world into two halves, electronics and not electronics, okay? And by divide like that, then B know for sure right now, okay, it's gonna be electronic device. Then next question might be that something like, can it connect to internet, for example? And the answer is going to be yes. Then all electronic device that cannot connect to the internet gonna be rejected from the search space. So this is the concept of divide and conquer. You divide the possibilities in half, and then you check which half is gonna be detected. And that is concept of most of efficiency, like most effective searching algorithms. So it's like you're playing a game and then you try to find out like which part is going to be. So yep, that's kind of idea. And binary search do it that way. So you look at binary search here. So what you're gonna see in the binary search is the way it do is divide the chunk of data by half. So you doesn't have to care how long data is gonna be. It might be like 1 million, 10 trillion. Then you find the middle point of the data first. You check that the value that you're looking for is higher or lower than that specific middle point. For example, like right here, the middle point is 23, okay? The middle point is 23. Then we're looking for 37. We know that 37 is higher than 23. Then the data should be, the 37 should be on the right half. Then we divide it again in the middle point, compare it, and then we're gonna have like smaller and smaller and smaller chunk. So the searching time is gonna be much, much faster than linear search in this kind of sense. And most of searching algorithms, even the complex one that you might see in literature or in advanced algorithm class, is always do everything with the divide and conquer logic behind. So divide and conquer is very, very good like logic set that you should keep in mind as a tool. Like whenever you're gonna write something, like write some code that need to searching or do some sorting, if you can make it to be divide and conquer strategy, not something that linearly searching or linearly sorting, it's gonna be very, very effective, much faster, less computational times. Okay. So the idea, the thing that I left on this slide is that asking you guys to thinking about pseudocode of linear search and the pseudocode of binary search as well. So does anyone did that already? I mean, by yourself? Does anyone do that? I mean, for linear search, it's gonna be very, very kind of, I would say like linear search is very, very simple pseudocode that you can imagine in mind. Oh, wow. Okay. Some of you already put it up on GitHub. So you do linear search, binary search, selection sort as well. Wow, that's good. It's great that you become like this kind of heavily active on that. I mean, if you want to do any further project on that, like not related to class at all, you can come and contact me as well. There are a couple of work that going on in our research group that if you want to get involved. And anyway, it's not like you doing pseudocode at all, you code or all the thing down in Python already. Okay, that's good. Great, great. Like then come back to some basic stuff that like other people in class might be able to follow. Does anyone already made the pseudocode or thinking about that at least? So I will open the whiteboard and then can anyone please at least write down the pseudocode of linear search? It's going to be pretty simple, straightforward one. Or you can open the microphone and talking about it, trying to like give me kind of solution. Verbally is fine, or writing it down in chat is also fine. anyway, like in this kind of situation, in the COVID-19 situation, the first thing that you have to consider is how safe you and your family is. So if there are anything that you need to do, like, I don't know, moving out the stuff, go to the safe place or whatsoever, and it's going to interrupt your life and you cannot do the class anymore, you can contact me and TA and talking about your situation, because your safety is like the first thing that we concern. And then you can, relearn and learn later on in the online material that we provide, and then making discussion one by one later on if we have to. Okay, no one getting involved in this, then I'm gonna skip it because like it's pretty easy one as well. But you can imagine that linear search, since we're gonna check for each data point one by one. So it simply can be done in one for loop, right? So you just run one for loop and then check each data one by one. The solution is going to be pretty simple. It's like you run one for loop, then it's going to be enough, because you're searching for each data one by one. It's not going to hurt anything anyway. So it's going to be that simple. But then to thinking about something like binary search, it's going to be more interesting. Like how you're going to derive this data, I mean, this kind of idea to be pseudocode. I want to see it as well. So these two questions, if you didn't do it before, please doing that, then I'm going to put it to be assignment for today. I mean, to be real assignment, more than just some task that asking you to thinking about and discuss in a live session. If you want to have low amount of assignment, I would like you to get involved and talking and have discussion in class more than just, like be passive. I want to have active class as well. It's not fun and not easy to talking alone with the microphone. And yeah, the idea of the binary search itself, as you see, I also raising some good case scenario and bad case scenario for binary search in comparison to sequential search here in the slide, which you will see in the video as well. So yeah, I think I'm gonna put some guide here, maybe a little bit about binary search, how you can implement it is okay. So first of all, like in your data structure, if it is array, it's gonna be more simple to do. But if it is linked list or trees, then you need to have any kind of function that's gonna help you to find the length of the trees or length of the linked list, because you need to divide it in half. So the first thing you need to do is you need to be able to find the middle point. That might be the first thing that you should do. Then next step, after you find the middle point, which might be here in the case, then next step is you compare the value here. You compare the value here and the value that you're looking for. For example, if here is number like 10, but you're looking for 11, what should you do? So we sub the data point and the data type in half, right? So it's like we need to have feature that can divide the data structure into lower half and higher half. And you just keep only the part that you still need to searching for the solution. So that's kind of idea. So you need to be able to divide. So what we did is we not actually really divide the array in half. We can simply do by keep the index of the array that we still searching for the information into the feasible space, feasible range of data that we're looking for. Because here, the solution is not going to be there for sure, right? Then we check, just simply check anything starting from that middle point until the end of the array. And you can keep doing that one by one, okay? Then here, by divide the data that you and storing the range, then you should be able to input the current range that you're looking for and the middle point. Okay, there's a couple of things that you can put as input, and then the function can then you have to imagine that this function have to recursively run again and again and again and again until you're searching for the solution. So it need to design to be more modular, more like function that you can reuse with the same amount of input and the same amount of output. Okay. Then ultimately you can do it to be recursive function. Okay. Yeah, that's the idea for binary search, and you keep doing that until the end is going to be finished. Then I would like to move to something more complicated than that. So we go back into the slide. Okay, we go back to slide, and I would like to mention that because binary search is going to be effective or workable in the sort data type only, then we're talking about more of sorting algorithms that can starting from like many type. I love this slide a lot, and I want to show it to you guys again. That just want to remind, this is very good animation that run by somebody else. Yeah, by this slide, then you can see that our sorting algorithms gonna be fast or slow depend on many kind of situation. First, the initial state of the data. So it's starting like a random information or nearly sorted information or reverse information or like few unique point information. It's also interrupt the performance of algorithm as well. The other thing is the algorithm itself, because each algorithm has like different efficiency in different kind of situation. So this slide mainly just want to keep you guys in mind that not like every single sorting algorithm that you learn, not just from now, I think you're going to learn much more, like heap, sort, or merge sort in algorithm class. Those are going to be useful in some specific situation, even for the algorithm that looks like is not going to be usable, is too simple, is too slow in your kind of sense. But then most of the time it's still possible to find the application of that specific type of sorting algorithms. Okay. So the question that I raised here is for selection sort. Does anyone take a look at it? I will recap it again. Selection sort is something like very simple. You find the minimum value in the array and then bring it out to be the sorted information. Then again, you're searching for the minimum value again and bring it out. Keep doing that. It's like you shuffle a deck of cards, you try to sort it, but then you do it in the simple way. Try to looking for card number 1 first, bring it out, looking for card number 2 and bring it out, number 3, bring it out, 4, bring it out. So repeating this process, in the end, you're going to have sorting deck anyway. It's going to be this kind of simple. Then I'm rising up the question that, okay, I know that pseudocode or flowchart of this one is not going to be interesting. It's pretty simple. You looking at the array, find the minimum value, bring it to the font. Okay, just that simple. And then you keep repeating it. But again, you need to make it to be modular. You need to make it to be function that can run itself again and again with the same amount of input. So the design of function is something pretty crucial right here. And I want to see is as well, it's possible if you're not doing it at all, then I'm gonna ask it to be the assignment for design of code, this simple algorithm as well. And okay, the second question that I'm raising right here is that what is the pros or the benefit or any kind of situation that we should use selection sort more than any other kind of sorting algorithms? Can anyone like guessing which situation that we should use selection sort more than anything else? Okay, please, like anyone, maybe I can randomly unmute microphone of some of you and then asking you guys one by one if you're not gonna talk with me at all. Okay, then you don't have microphone. Sorry, selection is good in small list. Yeah, that's one kind of case. If you know for sure that your data structure is pretty small, it's also used. Can we use selection sort in case of rechecking or data in the structure? Yes, you can use it in that case, but then imagine that it look like you repeatedly do the same thing with linear search in selection sort, right? Because you need to searching for the minimum value first, and then you starting to bring it out one by one. So it's more like you do two things in the same time. You do linear search for minimum value, and then you bring out that information one by one, and that's not going to be effective in many kind of sense. But actually, like the answer is compare one by one with the minimum value, if I'm not mistaken. Yes, and that, yeah, I mean that's right. But then, as I say again, like the number of iteration that you have to do, the number of computation time is going to be too high compared to any other application. No, any other algorithm, sorry. But then the good point of selection search is actually how many times that you write the information. Thinking about this way, so we looking down to other algorithms like bubble sort. For example, in bubble sort, how you do is you compare two value, right? If the left one is higher than right one, then you swap. When we say swap, what actually did is you write the information of right position instead of the left, and you write down the value on the left to the right position. It's like you're writing information 2 times for each swap, okay? And every time that you do the swap in the bubble sort, it's gonna create a lot of writing in the actual physical memories. You need to write information in the different location one by one again. And also, if you look at quick sort briefly, again, we need to make comparison with P1. We need to make comparison between high and low value, and then you need to swap position again. every time that we're talking about swap, it means you need to write down information in the actual memory. So the reason that I need to raise up this question is because it's directly related to your department. Actually, you work in the control system, and many control systems still use flash memory. Did you know flash memory? Like, does anyone know what is flash memory? Okay, like starting by no. Does anyone know? No, not at all. No one really know that. I mean, oh, I'll Google it. Yeah. I mean, flash memory itself is like the kind of memories that, like the black circuit that put on the circuit board, is the kind of memories that you need to burn down information in transistor. And when I say burn, it means physical burning. You need to wire and rewire the circuit again. Good thing for the flash memory is they will keep information in that memory even though you doesn't connect any electricity inside. So it's not going to be kind of like some information like RAM that it can be randomly, it's like USB. You can thinking about that. But then the thing that we have in our PC and using flash memory is BIOS. Thinking about BIOS, like you cannot open your laptop, you cannot open your PC if your main board doesn't work, if BIOS doesn't work, because computer didn't know how to start. When you press the starting button, it just like put some electricity inside, and the BIOS is the actual memories that keep how the circuit inside wiring to each other and where the computer should start from north grid to south grid to the main board to every single part. So in control, like in control management, and if you work on the front line in the extreme situation, for example, if you work offshore, if you work in the manufacturing site that have high temperature, high humidity, for example, flash memory is going to be very, very useful because it's very tolerant. Like some of you might have the same mistake like me. You put the flash drive in your pocket and then without carefully checking, you put all your pants and your shirt to the washing machine, and then you wash your USB drive, and then you think like your life is gonna end. It's like you lost that stuff forever. But then if you dry the USB drive before you plug it in again, the memory is still there. It's not gone. The problem is flash memories have physical limitation of how many times you can write down the information. For example, like some flash memory, like solid state drive or USB drive, you can write information much more times than you can imagine. So you're not gonna be worried about this. But then in specific type of flash memory that you can use in iron manufacturing or offshore situation in petrochemical side, that the temperature inside the factory is something around like 100 or 200 degrees Celsius in the operation kind of situation. Your control board need to survive that kind of heat, that kind of humidities. And those specific type of flash memories that can survive heat and humidity, maybe like some of them can write down information for just like 10,000 times. That's the maximum. And then you cannot write anything anymore because it's gonna broke, like completely broken, like brick. So that's why selection sort is pretty useful in that kind of situation, because you can write down information only 10,000 times, for example. If you do the bubble sort of, just imagine like 100 point of array, you swap information much more than 100 times for sure. then you can do bubble sort for just only 100 times. Then you need to buy new memory and plug it in your circuit. That's not going to be the way that industry work, because memory also costs some like money. You need to pay for it, and you need to stop the operation line to replace the memory, and that's going to cost a lot of money and time. So selection sort for you guys going to be useful in that situation when you, when you go to the internship in the company, or you work with the real like control circuit board that use flash memory. Please keep in mind that flash memory have limited amount of times that you can write down information. So if you're going to do sorting, please use selection sort if possible to save the lifespan of your memories. Yeah, that's the answer. It's a little bit complicated, but then in some sense, I think that's kind of information that's useful for all of you guys that work, mostly going to work in manufacturing side, I think, or in semiconductors industry. Okay. Yeah, and again, the bubble sort and selection sort is pretty simple algorithms. So I think the pseudocode is not going to be complicated, and you can make it down by yourself. I'm not going to worry so much about this. The only thing that I worry about is quicksort. Does anyone still have no idea how it works after listening to the video and the animation that I try to navigate you guys along how the quicksort work? Do you really understand how it works? Is there any question about quicksort? How it works? It is a different method on internet? Yes, of course, for sure. That's why I mentioned that quicksort itself have many variations. So when it's come out, like the most simple one that I'm teaching here is, I think it seems like 1960 something. But then in internet, you're gonna see different variation of quicksort. But then all of them gonna work with this divide and conquer logic anyway. So which method that you're looking for in the internet and try to implement right now? Like if I go back to the very first slide here, you can see in this slide as well that I mentioned that they have like quicksort, normal quicksort, and a quicksort tree, which is another variation of quicksort. So the quicksort itself have a lot of diversity and many ways to do that, but then the idea is you divide and conquer. It's kind of like strategize around that divide and conquer logic. So try to sorting data until it divide into two parts. The part that lower than P1 and higher than P1, and then you keep repeating that again. So it seemed like most people understand how quicksort works from the video. So I didn't, then I don't think we need to discuss more about that. Yeah. So far, still good, I think. If there is no more question, then the idea is that I think I really want to like give an assignment to implement the quicksort, and I want to see from the I want to see from pseudocode or flowchart. You need to deliver two things, either pseudocode or flowchart plus the source code that you implemented in C or in Python. Then the quicksort is going to be quicksort for array, the simplest one, I think, that you can implement it. So that's going to be assignment that I'm going to give for this week. Implement quicksort, okay, and deliver pseudocode plus flowchart of it. If you implement, does quicksort require recursion? Not really. Like iterative algorithm itself, all of them can implement in recursive. kind of sense. It can be recursion, but you can implement it as a simple iteration as well. It's still workable. But I need to mention that if you can implement it to be recursive function, then it's good for you if you are if you aim to be programmer in a big company in near future. Because of the test, like the test if you want to apply to a big company in Singapore, for example, they're gonna look at the speed of the code and the memory containing of the code. So sometimes you need to making a trade-off as well. If you use a recursive, then as a recursive function, you need to hold information a lot in RAM in the memories. And the recursion can create a stack overflow, like kind of issue in the memory if you don't design it well enough. That's why we use the word iterative function more than recursion, because even though you can implement it in recursive way kind of sense, in many practical situations, we didn't use recursive function that much. Okay, so quick thought for Pattarapong. I think if you want to implement it in a different way, different method that you found in the internet, it's still fine for me. You have to describe it a little bit more in your pseudocode or flowchart. Maybe have some text to giving some description like how it works, what is the logic behind that. Then the TA can recheck it. Okay. Then I would like to. Okay, good. Then I think that's all for like the people who doesn't have any more question. Again, I would like to mention that the solution of the previous assignment and stuff, I'm gonna provide it for sure. But then now we spend more and more time to prepare the material online for you guys. So solution gonna be delivered after that. Whenever we finish all those video editing, recording, and preparing material, because it's not that easy for me to prepare the class or talking with the microphone without seeing the face of the audience is pretty strange for me as well. It's the very first time that I'm doing this. So if there are any feedback that you want to, giving to us to improve the quality of video or improve the quality of learning in general, please give feedback to us. If we can do it, we will try with the equipment that we have right now. Okay. Then after this, I want to spend time to talking about some question that I found in the group. And I think it's quite interesting. And I think it also came from you again, Pattarapong. Okay, yeah, one more thing that I want to show to you. Oh, sorry. Is this website. Okay. So I think you're gonna see this website already. Yeah, geeksforgeeks.org. I think I have a problem with my internet. Okay. You mean for the live session, right? Then, okay, sure. Then we will re-upload it in YouTube. Okay, you can recheck it, and hopefully you can follow it through. If you have any question, you can put it down in the Facebook. Okay, okay, I see. Like, okay, you can hear only the voice, but you cannot see the video. Huh. Well, sorry to hear that. Then this might be your internet problem or maybe your connection with Zoom. But then I highly recommend this website for you guys because it's very good for start learning programming. And they have some code challenge as well, which is divide the difficulty level, depends on your expertise. And also it have solution of every question in many languages. For example, because this one is not it's not gonna be that serious for me. Yeah, if you look at linear search right there, you can see that they have some example implementation in both C, Python, Java, C++, C Sharp, PHP. So it's pretty good website that you can looking for solution and practice, because like I try to giving you algorithm first, and the way we implement the code from the algorithms is still depend on the person to person. Okay, because like the style of code, how you interpret that feature to be the code, is can be differently differentiate from person to person. So algorithm itself doesn't need code. You writing down algorithms in paper, if you're following through that, you can solve the problems. That the definition of algorithms. But in the code that you see right there is just one kind of implementation of algorithms. So that's why, yeah, I'm not really care that you're gonna see solution online in internet. But then when you submit your assignment, I asking you to submit two things, both pseudocode and also your solution. Then if you didn't do it by yourself and looking for solution internet, then you're gonna suffer anyway for the either project or final examination that we're gonna do later in the end of the semester. Okay, because in that one we're gonna do the interview of how, if we do it like project based, then I gonna do some interview anyway to make sure that you do it by yourself and you understand how it's work, how it's run. Okay, I think that's all for most of you, but then for some kind of like serious question of Python coding, I found one in the group. Not really sure from Patapon or not. You already solved it, or did you know why it's not work already with that Python OOP question? I tried to looking for it. Not yet. Okay. So that one is going to be not really related to data structure class, but then if, I mean, for most of you, if you want to stop it right here, it's okay. Okay, you can leave the meeting already. And how pseudocode be like? Pseudocode doesn't have format. That's what I can say. I think if you understand what pseudocode is, it doesn't have any format. It's not like flowchart. If you're not really sure how pseudocode work, then please write it down into flowchart. Okay. It's like hybrid of flowchart and source code. Not really, it's more simple than that. It's like human, like kind of sentence based. I don't think it needs syntax. Yes, it doesn't need any syntax. Yeah, it can be mathematical based like that as well. Yeah, that one is still okay. Okay, stay safe. Thank you everyone for joining this. And then I want to talking about this problem a little bit more with him. So the idea is that you try to do something like count, like you want to have count function. But now I think what you don't understand in this OOP design is how variable is being generated and be degenerate. I mean the lifetimes of variable itself. Because if you put it to be the function inside the class, what happens is that any self count here that you init here is not init as the, how to say, is not init to be the attribute of the class yet. So to put it simple, like class need to have attribute. If not, if you use just self dot something something, it means the data or variable that have the lifetime only in that function, even though you use init. Like, did you understand that idea? So it's like yeah, it's going to be pretty strange. But then if you want to init it and want the data to be last longer, then within that function, you need to declare it to be attribute of the class. That's kind of idea. But then self itself is like pointer to point down the name of variable that have lifetime in that function. Not really kind of like self point down to the attribute in that object only. It depends on the way you write it down. So self is pretty tricky in Python actually. And the Python OOP, what I would say mention as well is that Python OOP is not the real OOP. As you, I think you understand, I mean, you can code it this far, then you might understand some concept of Python. Behind that is still interpreter. Even though it can compile, it's not fully compiled languages. And the OOP-ish kind of way of implementation that we can do with Python is not provide the full range of OOP control as we can do in, I don't know, in Swift, in Go, in even in C++. So for me, it's good that you try to do Python OOP. It's good if you want to implement the website using Python, or we want to implement some kind of front end application using Python. But it's not still, I mean, it still cannot fully function as an OOP. Yeah, but then like this problem is mainly because of the life cycle of variable. It's gonna be very confusing, but you can test it. Like you try to like use the same variable again, like self dot something something in function, in attribute, and then you print it out from each line, and you see the sequence of it. Okay. Instead of print head, you print head and then you print self dot head separately. Then you're trying to see how it's interpret the variable one by one. Then it might help you to learn how self pointer work and the life cycle of variable that being pointed by self. That's going to be a little bit tricky, but you need to learn it one by one like that. Also, if you want to, if you write it like this, like in OP style, I highly recommend you to try to do some natural language processing kind of assignment. For example, try to implement Google searching box that you have a list of dictionaries in English. For example, like you have English dictionary, put it in Excel file or maybe in storage that you dump it in the memory later on. Then whenever you type each text, because in Google, it always come with suggestion, right? So when we type down something like, yeah, here for Google search, in the search box, whenever you type more than 2 words, then they will try to give you like kind of suggestion from their dictionaries. For example, like if I searching for kind of Python, then they have like the data that I'm seeing in history or the most search value or information gonna come in the suggestion list one by one. Okay. And this suggestion list, to make it more simple, you can do it with dictionary kind of sense. Like for example, if I type DIC, then they will have some list of suggestions like from dictionary to dictatorship to like those kind of words coming one by one. And then I can select it or making the suggestion list. But then if you design the data structure good enough, those can be done by data structure itself. Doesn't have to have any algorithm behind. It's a data structure that used in Google, and I think I'm gonna teach in the class as well. But then if you're interested in that, you can looking for it ahead of the class. Okay, it's called 3IE. Yep, it's pronounced like tree as well, like a trees, but TRIE, and it's used mainly like starting being used for that Google search box and derive and bloom out for any other application later on in natural language processing. So that's a pretty interesting one that you can try and implement it to be class and object and have some specific feature and attribute inside. That's kind of assignment, not assignment, but that's kind of practice that if you love programming this much, then I suggest you to try. Is there any other question from you guys? Because if not, then we're gonna end this session. Yeah. Patarahan, are you like have any other question? Yeah, Nhi Yang, thank you. I'm not really sure like who you are actually. Oh, you are the Chinese student from CPE, right? Oh, yeah. Stay safe, and everyone as well. Stay safe. I'm in this situation. I still need to lock down in my house as well, and have like pretty limited space to do this online teaching. So kind of very hard time for everyone, I think. Okay, I didn't see any auto reply from chat. So then I would say like thank you for today. Thank you for joining us, and please stay active in the Facebook group. We will try to upload the video as fast as we can. And yeah, see you around. The description of assignment we will post it soon. Okay. Thank you so much. Bye bye.